Assalamualaikum and hello everyone. My name is Muhammad Sudinesh bin Harul Azim, and today I would like to present about heuristic construction in non-routine problem solving. So let's get started. So in this video, I'm going to explain about what is a non-routine problem, and then we are going to see what is the characteristic of a non-routine problem, and then we are going to see the differences between a non-routine problem and a non-routine problem solving. And then we are going to see the 21st challenge which we are going to solve, and then we are going to see the heuristic solution by using computational thinking, and then lastly we are going to see about what is the relationship between computational thinking and a non-routine problem solving. First of all, what is a non-routine problem? A non-routine problem is a problem that cannot be solved by using a direct formula or a familiar method. It requires students to think critically, exploring new strategies, and then making decisions to find a solution. And these problems are usually unfamiliar, may have multiple solutions, and also requires justification, causing them to be more challenging and more meaningful than a routine problems. And research show that non-routine tasks often appear in real world or higher context where students must analyze and synthesize information, not just recall procedures. And non-routine problems also require students to plan their own steps and adapt their approach when solving it, since there is no fixed procedure. Students must try different strategies, identify patterns, and revise their thinking if needed, promoting deeper understanding and developing important skills such as reasoning and problem solving. Computational thinking research emphasizes that identifying patterns and structuring information is the key to solve a complex mathematical task effectively. Now, we are going to see what is the characteristic of non-routine problem. The first one is it has no direct formula or procedure, meaning you need to find the formula by your own and making your own procedure to solve the solution. And then it requires a higher order thinking, and it also has a multiple possible solutions or strategies. The next one is unfamiliar real-life context, meaning you are not so familiar with the problems, so it makes you harder to think. And the next one is it needs explanation and justification, of course. And then lastly, it requires a problem-solving strategies. And then we are going to see the differences between routine and non-routine problem solving. First of all, routine problem is a problem that follow a familiar method. Meanwhile, non-routine problem is a problem that require a new thinking. And then routine problem, you need only a direct application of formula or rules. But in non-routine, there is no fixed method. And then in routine problems, you only need a low order thinking, which is like recalling and applying. But for non-routine, you need a higher order thinking, which is you need to analyze and evaluate the problem. And for routine problem, it usually have only one correct answer. But for non-routine, it may have multiple correct answers. And for routine problems, it has a clear and structured steps. Meanwhile, for non-routine, it has a flexible and exploratory steps. And lastly, routine problem, you only need to apply what you already know. But for non-routine, you need to discover and construct solutions. And now, we are going to see the 21st century challenge. Now, let's see the scenario. A teacher has 32 students and she wants to divide them into groups for a digital project. But there is a conditions. The condition is each group must have the same number of students. The second one, each group must have between 3 and 7 students. And the last condition is there must be at least 4 groups that can be formed. So, the task is, first, you need to find all possible group arrangement. And the second one, you need to choose the best arrangement and justify your answer. So, we are going to solve the challenge by using 5 computational thinking. The first one is decompositions, where we break the problem into manageable parts. The second one is we're going to use pattern recognition to identify similarities or structures. The third one is we are going to apply abstraction to focus on relevant information. The fourth one is we are going to design algorithmic steps to guide the solution process. And then lastly, we are going to apply logical reasoning and evaluation to justify decisions. So first, we are going to break the problem into parts by using decompositions. So let's break the problem and see what we have. What we have is we have the total of 32 students, and the condition we have is the number of group size in a group must be between 3 and 7. And the last condition is we must at least have 4 groups. So based on all of this, we need to find the possible group sizes and the number of groups. And then we are going to use pattern recognition and divide 32 with the number 3 until 7. Why? Because the condition said each group must have the number between 3 until 7 students. So we are going to divide 32 with 3, 4, 5, 6, and 7. Okay, now let's see with each number. Now we have 32 divided by 3, and there is not a whole number, so we are going to remove it. And then we have 32 divided by 4, which is 8, and that's a whole number. And then we are going to see 32 divided by 5, and that's not a whole number. And the next one is 32 divided by 6, which is also not a whole number. And the last one is 32 divided by 7. So the only whole number here is 4. And now let's go to the next step. The next step is abstraction. So in this step, we are going to focus only on important information, and we are going to ignore unimportant information. So what is the important information? The important information is the total students, the group size, and the number of groups. And what are we going to ignore? We are going to ignore the name of students and the type of project, because that's not really important to this challenge, right? So we are going to ignore them and focus on the important one. And now we are going to make step-by-step solution by using algorithm. So the first step is we need to test group sizes from 3 to 7 like we did just now. And the second one, we are going to check the divisibility, which is 32 divided by 4, we will get a whole number. That's the visibility. And then the third one, we are going to calculate the number of group, which is 8. So by using the information, we are going to make a calculation, which is 32 divided by 4, and we are going to get 8 groups. By using logical reasoning and evaluation, we are going to check the conditions and make our own conclusions. So we all know that the condition is each group must have the number of students between 3 until 7. And based on our answer, we get the number group size is 4, which means we pass the conditions. And the second condition is there must be at least 4 groups. So our answer is 8. So we pass both the conditions. And our conclusion is we need 4 students with 8 groups. Now I'm going to give reflection on effectiveness of the heuristic. The first one, the heuristic was effective because it provided a clear and structured approach to solve a non-routine problem. Instead of guessing, the steps guided the process systematically from the start to finish. The second one is the heuristic encouraged a higher order thinking skills, which is analysis and evaluations. And it's also a decision-making skills when selecting valid solutions. But in this heuristic, there's also a limitations, which is it may overlook creativity if too focused on step and rules. The second one is it requires logical and abstract thinking, which not all students master it easily. And the last one is they are not always directly applicable to every real life situation. Number 4, it helps students to identify their mistakes and improve their solution through checking and revision. Number 5 is they can encourage flexible thinking by exploring and comparing different possible solutions. And the last one is it can be applied to other similar non-routine problems, making problem solving more efficient and transferable. Now we are going to see the relationship between computational thinking and non-routine problem solving. The first one is non-routine problems are complex and unfamiliar. So with computational thinking, which is decompositions, it's going to help break them into smaller parts. For example, like we did just now, we just split the 32 students into group size and number of groups. The second one is non-routine problems require exploration of possibilities. So we are going to use pattern recognitions to help identify value options. For examples, when we solve the question, we only need the numbers that divide 32 can form equal groups, which is 4. Because we all know that 32 divided by 4 is a whole number. And that's the only value option. And number 3 is non-routine problems include extra or real-life information, which is some of them are not really important to solve the questions. So we are going to use abstraction to help focus on relevant data. So for example, we just ignore the student details and focus only on numbers and conditions. And number 4 is non-routine problems have no fixed method. So we are going to use algorithm thinking by providing a step-by-step strategy. For example, systematically we are going to test group size from 3 until 7. And the last one is non-routine problem require justifications. So we are going to use logical reasoning and evaluation to ensure the solution is valid. For example, we just check if the 4 students per group meets all the conditions. Now, I'm going to show you why computational thinking is essential to non-routine problem. The first one is it can improve our problem-solving skills. By using computational thinking, it helps us thinking systematically and logically, making it easier to tackle unfamiliar problems. It also trains us to break problems into smaller parts, plan our approach, and make decisions confidently rather than guessing. And the second one is it can develop flexible and critical thinking. Computational thinking allows us to see multiple ways to solve a problem and adapt our strategies when needed. This flexibility improves our ability to reason, make informed choices, and learn from mistakes, which is very useful for real-life challenges as well as academic tests. Last but not least, I'm going to show you my references for this presentation. So, in this presentation, I use my references, which is Anggun Wahyun, Rehman, Subramaniam, Susanti, and Yi. And that is all from me. And thank you for watching this video.